Hey Dr. Lane, this is my video reassessment for chapter 16. This question says there are two very large disks of radius r carrying uniformly distributed charges QA and QB. They're zero point 0.1 millimeters apart, and the potential difference between the plates is VB minus VA equals negative 10 volts. It asks what's the direction of the electric field and invent values of QA and QB and R. That would make VB minus VA equal negative 10 volts. Um, so for the first part, since VB minus VA is a negative number, that means that VA is larger than VB, and that means that the direction of the electric field is going from VA to VB. And to find values for QA and QB and R, that would make VB minus VA minus 10 volts. First, I use the equation E equals negative delta V over D, which is the relation between electric field and electric potential. I change delta V for VB minus VA, and using the charge over the distance, I found that the electric potential is 10 to the 5th volts per meter. Then I use the equation delta V equals K over QR, and we need to find the charge, we need to find Q. So I set Q equals delta V R over K, substituted in VB minus VA, and I also know that to set Q, to find Q, I use the equation E equals Q over A over epsilon naught, and set those equations equal to each other. I know that the area of a disk is pi r squared, and so everything else is known. Everything else is either a constant or I calculated earlier or given. So I'll set up the equation R equals VB minus VA over K E epsilon naught. Found out that the disks are 4 times 10 to the negative 4th meters. It's the radius. And I use the equation Q equals VA minus VB times R over K to find the charge. Plugging in the information, I found that the disks have 4.4 picocoulombs, or I'm sorry, 0.44 picocoulombs, because pico is negative 12. Yeah, so 0.44 picocoulombs each. And since QA is larger, I would say that QA is positive 0.44 picocoulombs and QB is negative 0.44 picocoulombs.